So in this lecture, we're continuing with quantum mechanics, but I want to say something about uncertainty. So just reviewing what we've had, these were all the quantum rules. It's really only 5 because I don't really consider 5 a quantum rule. But remember, just to remind you, the states of a system are all normalized complex vectors in a complex vector space. The probability amplitude is given by this dot product, and when you take the magnitude squared, it gives you the probability. And then we said for every observable, there is an associated operator. And so, just to remind you, when we had our sensor measured up, right, left, these are the operators when we're in the z direction for up and down. This was when we rotated it sideways for the right and left direction. And this one was the operator for the in and out direction. Okay, and then we also said, here we have this eigenvalue. When we take this operator and we operate it on our generalized wave function, it gives me all the possible results of that measurement times back on my wave function, right here, or my state. And just to remind you, when we operated SZ on up, it gave me what we would get, h bar over 2 back on my up. And when we operated it on down, we got our other one, minus h bar over 2 on our down. Just like when we operate SX on our right, here is our right and left states, we got h bar over 2 right, and we operate on the left, we got minus h bar over 2 left. Here was our in and out states. When we do SY on in, we got h bar over 2i, and SY on out, we got minus h bar over 2. Remember, these right here are all orthonormal. When you dot them with themselves, you get 1. When you dot one with the other, you get 0. Same with these two, same with these two. Okay, and we also said we can write rights and lefts in terms of ups and downs, and we can write ins and outs in terms of ups and downs. And if we just wanted to write any state in terms of ups and downs, we could just plug it into this equation right here, where theta is how much you're pulled down from the up direction or z direction, and phi was how much you went around from the x or the right direction right here. Okay. and then this I tagged on, it's just more of a statistics equation right here. It said the average or expectation you get from many measurements of identical systems, if you have a whole bunch of identical electrons and measure the first one, read it out, measure the second one, measure the third, and find the average of all those values. It's given by making this sandwich between the operator. And then this last one, which we won't use for a little bit of time, which says if we operate H, which is the energy operator called the Hamiltonian on our state psi, this tells me how the state changes with time. So we'll worry about that more later. Okay, so I figured we'd get a little bit of review before I say something about uncertainty. So I said, let me just get some more practice on that. I said, let's just say we have a state, someone made a state psi, which was 1 plus I over the square root of 3 up plus 1 over the square root of 3 down. Okay, remember, these vectors should always be normalized, which means this squared plus this squared should be 1. Well, that squared is 1/3. This times its complex conjugate is 1 plus 1, which is 2. So this would be 2/3 plus 1/3. It's normalized. Okay, so if we asked, first of all, what is the probability of measuring up? Right here. Now we could just use this formula right here. Remember, you write the little dot product right there, and this is the state you're in. So you're in state psi, and you want to measure up. That's the probability. Okay, but we already know what this is going to be. It's just going to be this squared. This times its complex conjugate. Why? Because when you dot D with up, you get 0. So this is just going to be 2/3. Okay, and then if we wanted to get the probability of being down, again, we could do it with a down and a psi squared. But we already know what it is because it's just this squared, which is 1/3. And since it has to be one of the other, it has to add up to 1. Okay, well, let's say we want to get the probability of being right, of getting a right. So what do we want to do? We want to start out with our psi, and we want to get right squared. Well, if psi was written in terms of rights and lefts, then it would be much easier. So let's go ahead and write psi in terms of rights and lefts. Well, so first of all, what is u in terms of rights and lefts? Well, if we come back to here, if we just added these two equations, this would be gone, this would be right plus left, and this would be doubled right here, 2 over the square root of 2. But then we move it over to the other side, that'd be square root of 2 over 2, which is 1 over the square root of 2. So up is going to be 1 over the square root of 2 right, plus 1 over the square root of 2 left. And same with, we'll need to do it for down. Down, we would have just subtracted the two equations. So it's 1 over the square root of 2 right, minus 1 over the square root of 2 left. Okay, so if I were to write this in terms of rights and lefts, I'm just going to put this in place of it. So this psi becomes 1 plus I all over the square root of 3 times up, and I'll put in this whole thing. 1 over the square root of 2 right, plus 1 over the square root of 2 left, plus 1 over the square root of 3, and then we put in down, which is this one. 1 over the square root of 2 right, minus 1 over the square root of 2 left. Okay, so now I've written everything in terms of rights and lefts. I might as well combine the rights and the lefts. So everything with the right should be 1 plus I over the square root of 6 so that takes care of that term. And then over here, we just get plus 1 over the square root of 6. Okay, so there's all my rights, and then my lefts. We got this term, which is 1 plus I over the square root of 6. And then this last term is minus 1 over the square root of 6. Okay, so now it's a little easier for me to do this. It's going to just be just like we did up there. This term, when you cross R with L, right with left, you get 0. So the only thing it is, it's just this times its complex conjugate. Right there. That's all this is going to be. So the probability of right is just this times its complex conjugate. Before I multiply it, just this, I can put together the two 1s, so that's 2 plus I all over the square root of 6. And now I want to multiply it by its complex conjugate, which is 2 minus I all over the square root of 6. So the probability of being right, well, this is always just the first squared plus the second squared. So it's just 2 squared plus 1 squared, which is 5/6. Okay, and then the probability of being left would be this times its complex conjugate. So the probability of being left, we know what it's going to be because it has to add up to 1, so it's going to be 1/6, but just to check. You notice here you get the 1 minus the 1, that's just I over the square root of 6. And then we have to multiply it by its complex conjugate, which is minus I over the square root of 6, which is 1/6. So the probability of left is 1/6. Okay, now I could have measured the probability of in or out also, because we can write in terms of ups and downs, because if I add these two together, these two drop out, and we get in plus out equals 2 over the square root of 2 up, or up equals square root of 2 over 2, in plus out. So if we go over there, we got in is equal to, up. We wanted to write up in terms of ins and outs. Up, we just said, was 1 over the square root of 2. I plus 1 over the square root of 2O. And down would have been minus 1 over the square root, minus 1 over the square root of 2. If I had subtracted the two equations, I in plus I over the square root of 2 out. Okay, so I could have taken those two and plugged them into here and here, and we could have gotten that one too. And I'm not going to do it. I'll just tell you what the probability of in is 1/6, and the probability of out is 5/6. Okay, now if we go back and look at, say this, we want to get the average value of S in the Z direction. So what if we wanted to get S sub Z average? So that means if we had a whole bunch of these electrons, not just one, they had a whole pile of these. We went along here and we measured our sensor in the up direction. So here was our sensor in the Z direction. Measured the first one, read it. Measured the second one, read it. Measured the third, and got the average of all of those. We don't want to read the same event twice. We have to read one. Once we read it, we throw that one away, get another one. Okay, so remember, we said this is a sandwich. It's S sub Z, it's psi, S sub Z, psi. Now, one way we could have done this is done it all with matrices right here. We could have turned this into a column where this would have been on the top of the column and this would have been underneath of it. And then we could have turned it into the dual, turned it into a row, made the complex conjugate. That would have been this. We could have put the matrix that we had over there for S sub Z in there, and we could have put the psi in there and worked it all out with the column. But it's a little easier if I just use this information over here. We know S sub Z on up is this, and we know S sub Z on down gives me that. So let's just get the let's just worry about that part right there. S sub z acting on psi. We're just going to look at that part first. Well, psi, we can put in what our psi is. That's S sub z acting on 1 plus I over the square root of 3 up plus 1 over the square root of 3 down. Okay, so when I operate, this can all be brought out in front. So this is 1 plus I over the square root of 3. Now S sub z on up, we just said, gives me h bar over 2, back my up again. Plus 1 over the square root of 3. Don't let that change. 3. S sub z on down is minus h bar over 2, back on my down again. Okay, so we did this much of it right there. So now I can just dot this with my original psi. But I have to turn this into a bra right here. Remember, to turn that into a bra, I take the complex conjugate of this, turn that into a bra, take the complex conjugate of that, turn that into a bra. So just this part right there will be 1 minus I over the square root of 3, bra up, plus 1 over the square root of 3, bra down. Okay, so there is that term. Then we have to do all of this, but we already did all that. It's right here. So that's the rest of it. So we've got this now. So we got 1 plus I all over the square root of 3 times h bar over 2 up plus 1 over the square root of 3 minus h bar over 2 down. Okay, now I just have to multiply this through. We already know that up is 1, up down is 0, down up is 0, and down down is 1. So I don't have to worry about the cross terms. So just multiplying these two together, 1 minus I times 1 plus I is the same, it's just 1 squared plus 1 squared, which is 2. So that gives me 2, this times this, all over square root of 3 times the square root of 3, that's 3. And then we already have the h bar over 2, h bar over 2. And then we had the up, which is 1. Okay, so that takes care of this times this. And then the only other term we have are these two. And so multiplying these two together, it's a negative number, so I'm going to have a minus. I get a square root of 3 and a square root of 3, that's 3 times 2 is 6. So you just get h bar over 6. Well, this is 2h bar over 6 minus 1h bar over 6, which is just h bar over 6. So that would be the average value if I took let's say thousands of these and tested each one and read them out. Every time I get a 1, that's really an h bar over 2. Okay. So, and again, if we really wanted to do it a little bit easier, we could have just said, well, much easier, we could have just said the average is just the probability that you get an up. Where's our probability of up? Which is right here. Probability of up, we could have also said the average S sub z is the probability of up times the value you get, which is h bar over 2, plus the probability of down times the value you get, which is minus h bar over 2. We could have done it that and it would be much easier. Because this Probability of up was 2/3 h bar over 2. And then the probability of down was 1/3. So this is minus h bar over 6, h bar over 2. So you got 2h bar over 6 minus h bar over 6, which is h bar over 6. So pretty soon you might just do it this way. It's so much simpler. Okay. We could have calculated S, we could have done the average of y's, S sub y, and S sub x. We could have done that also. Okay. But I think what I'll do is I'm going to, you know, right here, when we calculated the average value, this is the average value. Usually there's more information you want than just the average value. Because usually, you know, when you, let's say these are your values along here, and you get something that looks like this, and there was your average value. But another number that's very important is the width of this, how wide this is, you know, how much of your numbers distributed in your average. And usually, the way we measure the width of some sort of a peak, we usually call that the standard deviation. So this is usually called standard deviation. It's really around the mean, how much it deviates around the mean. And normally the way we define it is, if this is like this, it doesn't have to be this shape, but if it is, if this area is 1, let's say the area of this is 1, then if you go over plus or minus 1 standard deviation, this area corresponds to 68% of the entire area. That's the way we're going to do with a standard deviation is defined. It's defined as 68% of the entire distribution. How far out do you have to go so that you get 68%? And that would have been plus or minus 1 standard deviation. Well, there's actually an equation for standard deviation. The equation for the standard deviation is just standard deviation. It's the square root of, now what you do is you sum up how much the values of each one it is, each one minus the average. So it'd be the sum over all your data right there. What the value is, I'll just call it x sub I, minus the average of x squared. You need to square that because over here, if you didn't square them, you'd get just as many positives and negatives, and you'd always get a 0 then. Divided by how many items you have, n. That's the definition of the standard deviation. Well, what if we just, I'm just going to square this thing out. So the standard deviation is the square root of, if I square this thing out, I get, the first term is x sub I squared, so you got the sum of x sub I squared. Then the next term, actually let's just put the parentheses in, and then the middle term is minus x2, minus 2 x sub I times the average of x, just squaring that out. And then the last term is just plus the x squared. Okay, so I just squared that, and you're dividing it by n. How many terms? Okay, and so what I'm going to do is I'm just going to put the sum with each term right there. So this standard deviation is the square root. So the first term would be the sum of x sub I squared over n. And then the next term would be minus, and I can pull out, that's a constant, and that's a constant, minus 2x times the sum of x sub I over n. And then the last term, I can pull that out, so you got plus the x squared, and I got the sum of, well, there's nothing left, sum of 1 all over n. Okay, well, so now you notice right here, you're taking the square of each number, adding them all up and divide by n. Well, what is that? That's the average of x squared, because the average, this is the average. The average, you add them up and divide by n, that's the average of x, but this is the average of x squared, because you're taking x1 squared plus x2 squared plus x3 squared and divided by how many there are. So this one, this first one is x squared, the average of x squared. This is minus 2 times the average of x, but this is the average of x, so that's squared. And then this, what's the sum of 1? How many terms you got? You got n terms. You got 1 plus 1 plus 1 plus 1 plus 1, n times. Well, that's just n, and that n cancels with that n. So this is just plus x squared. Well, I can combine these two together. I can't combine that because the square is inside. So it looks like the standard deviation is equal to the square root of the square of the average minus the average squared. Oh, okay, so that's a definition for the standard deviation. So for us, we're not going to call it the standard deviation, we're going to call it the uncertainty. Uncertainty. And we're going to use that symbol for the uncertainty. Why? Because we used it for the uncertainty in x times the uncertainty in p. But we do it for an operator, right? For a certain measurement. So the uncertainty of an operator, or a measurement, remember that's associated with the measurement, that's just going to be the square root of the operator squared average minus the operator squared. Okay, so now not only do we get an average here, but we also get the standard deviation of this average right here. And so we can say, let me get over here on this side, we can say the uncertainty in the operator is equal to the square root of the operator squared minus the operator squared. Remember, the square's inside, the square's outside. Okay, so now that we have this, maybe we should ask for this problem that we've been working on, what is the uncertainty in, say, an operator? We'll just say S sub z. What is the uncertainty in S sub z? So when we measured all these, and we took this and we put it into our machine and we measured all the values, we're going to get all these little values all over here. And we already know what the average was. The average was h bar over 6. But we'd like to know how much they spread out among that h bar over 6. So what do? We just come over to here and we plug in the square root of S sub z squared minus S sub z squared. Now we already know what S sub z is. That's h bar over 6. So I know what this one is. This is h bar over 6 times h bar over 6. So that I know. That's h bar squared over 36. So I already know that one. Now I just need to get this one right here. I need to get s sub z squared. That's what I need to get. Well, we go back to our rule, which is right here. S sub z, you just sandwich it in. So this is just going to be psi s sub z squared. S sub z. Instead of saying squared, why don't I just say s sub z times s sub z? It's the same thing as s sub z squared. Back on my psi. Okay. Well, the reason why I want to do that is because I think we already did this right here. S sub z on psi, we did it right here. It's right there. So, what do I want to do with that? If I plug this into here, then I want to do another s sub z on it. So we're going to do, so now what I'm going to write out is just this much of it. I'll just write out that much. So we have our s sub z right there. And then we had this, which we already calculated, which was right there. So let me put that in. That would be 1 plus I all over the square root of 3, h bar over 2, up, plus 1 over the square root of 3, minus h bar over 2, down. Okay, so now I just want to do this again to it. We already know that sz on up gives me another h bar over 2, and s sub z on down gives me another minus h bar over 2. So by plugging this in, we're going to end up with 1 plus I over the square root of 3, 1 plus I all over the square root of 3. When I do this, I get an h bar over 2, but I have another one, so it's going to be h bar squared over 4. H bar squared over 4. And then plus 1 over the square root of 3. Times, I got an s sub z on the down, which gives me minus h bar over 2 down, and I already have another h bar over 2 down, so that's going to be a plus h bar squared over 4. H bar squared over 4. I still got the up here, because s sub z on up gave me h bar over 2 up, so I still have my up here, and I still have my down over there. Okay, so that much is this. Now I just have to put this at the beginning of it, like we did before. We need to put this, remember that was my bra of psi, in front of it. So we'll write all that out. So now we've got psi s sub z squared psi is equal to my bra first, 1 minus I over the square root of 3, up plus 1 over the square root of 3, down. Okay, so that takes care of this, and then we have that. But that right there is everything that was up there. So we have 1 plus I over the square root of 3. H bar squared over 4 up. plus 1 over the square root of 3 h bar squared over 4 down. Okay, now when we multiply this through, the only ones we have to worry about is these two and these two. So I should say this always has to be a positive, right? Because we're finding the average, whatever you measure squared. Whatever you measure squared, remember, whatever you measure is a real number, and then when you square it, it's always positive. So I should end up with a positive for this term right here. Okay, so this term, not only that, but this term should always be greater or equal to this term. Why? Because I can't have a negative in here, otherwise I'd have a complex for an uncertainty. I can't have that. Okay, so multiplying this together, 1 minus I, 1 plus I, again was 2. We got 3 square root of 3, that's 3. And then we also have the 4 there. And we have the h bar squared. And the up gave me 1. And then we have these two multiplied together. Plus, square root of 3 is 3 times 4 h bar squared. Down, down. Okay, so now we've got 2 twelfths plus 1 twelfth, 3 twelfths h bar squared, which is 1/4 h bar squared. So we've got this term, we've got that term, now we can get the uncertainty. The uncertainty in S sub z is the square root of this term, which is h bar squared over 4, minus this term, which is h bar squared over 36. Well, this is 9/36 minus 1 is 8/36. So this is the square root of 8/36 h bar squared. I can bring out the h bar squared, bring out the 36, and just take the square root of 8. So you end up with 2 square root of 2 h bar all over 6, which is equal to the square root of 2 all over 3 h bar. So square root of 2 over 3, that's around, square root of 2 is 1.41 divided by, that's like about a half of an h bar. Half an h bar. So that tells me kind of, when we were looking at our average, h bar over 6, so that means if you were to plot it out, you know, this is the what I measure, and we said the average was h bar over 6, but it's going to spread out by, this was what, h bar over 2, about 66%. This is h bar over 2 and h bar over 2. 68% of them are within this range right here. So that's what they mean. It just tells me how much we're spreading out, and we need this because we have these Heisenberg uncertainty principles, and we need to get it to get later on when we need to get our delta x, delta p. You know, this is how we'll get it. We'll use this formula right here. So now, these are the only two formulas we needed for statistics. I don't really call them quantum mechanics rules. They're more statistics rules. So really, we only have 1, 2, 3, 4, 5 rules right here. I mean, there's only 5 rules of quantum mechanics. Okay, so now the next lecture we'll look at what happens if we have more than one electron, or another word we're calling these is qubits. What if you had more than one qubit right here? So, okay.